Welcome. In this module, we will explore Platform as a Service, or PaaS. This model is a game changer for developers and businesses who want to build and deploy applications without the headache of managing the underlying hardware or operating systems. Let's define exactly what PaaS is and why it matters. To define PaaS, think of it as a complete managed hosting environment. As noted in the sources, in a PaaS model, the cloud provider manages the virtual machines and networking resources, and the cloud tenant simply deploys their applications into this managed environment. This allows you to focus entirely on the application code rather than the infrastructure. It is not just about raw compute. PaaS provides a complete framework including middleware, development tools, and business intelligence services that developers can build upon to create sophisticated cloud-based applications. This flowchart illustrates the PaaS workflow. On the left, we have the developer who focuses solely on deploying code. They interact with the PaaS platform, the central blue node. Notice how the platform abstracts away the infrastructure layer on the right. The developer doesn't touch the servers, storage, networking, or the operating system directly. The platform handles all of that, allowing the developer to focus on the application logic. In the PaaS architecture, the division of labor shifts significantly compared to on-premises or IaaS models. The provider takes responsibility for the back-end infrastructure, which includes the compute, storage, networking, and security layers. Crucially, they also manage the operating system, middleware, and runtime environments. Your responsibility as the customer is streamlined. You manage the applications you build and the data they consume. This model frees your IT staff from routine tasks like patching operating systems or maintaining physical servers, allowing them to focus on higher-level organizational needs. This class diagram visualizes the stack. The top block, Customer Manages, contains only two items, applications and data. This is your domain. Everything below it falls under Provider Manages. This includes the runtime, middleware, operating system, and the entire physical infrastructure stack. The arrow indicates that your applications run on top of this massive, provider-managed foundation. Understanding PaaS requires understanding the shared responsibility model. PaaS sits in the middle of the spectrum. The cloud provider is always responsible for the physical data center, physical network, and physical hosts. However, you are always responsible for the information and data stored in the cloud, the devices that connect to it, and the accounts and identities of your users. For elements like identity infrastructure and network controls, the responsibility is often shared or configured by you within the provider's framework. We can visualize the shared responsibility model as a pie chart. The larger slice represents the provider's responsibility, covering the physical infrastructure, operating system, and middleware. The smaller slice is the customer's responsibility, strictly focused on data, access, and the application itself. This visual reinforces that, while PaaS offloads a significant burden, you still own the critical security aspects of your data and users. Why choose PaaS? First, it increases speed. PaaS allows developers to create applications faster by using built-in software components, reducing the amount of coding required. Second, it is cost-effective. The pay-as-you-go model allows organizations to use sophisticated development software and business intelligence tools that might otherwise be too expensive to purchase outright. Third, it supports distributed teams, allowing developers to work together on projects regardless of location. Finally, PaaS services generally come with built-in scalability and load balancing, ensuring your app can handle traffic spikes without manual intervention. This mind map breaks down the core benefits of PaaS. Starting from the center, we branch out to speed, driven by pre-coded components. Cost is minimized through the OpEx model. Productivity is boosted by enabling remote collaboration and removing infra tasks. Finally, scalability is achieved through built-in auto-scaling and load balancing features. PaaS is versatile. A primary use case is providing a development framework. Developers can build upon this framework to develop or customize cloud-based applications, similar to creating an Excel macro. Another common scenario is analytics and business intelligence. PaaS tools allow organizations to analyze and mine their data, finding insights and patterns to improve forecasting and product design decisions. Additionally, PaaS offers services like API management, security, and directory services to enhance your applications. This diagram maps the PaaS platform to its key use cases. The central PaaS node feeds into web and mobile apps for user interaction, analytics and BI tools for generating business insights, and API management for secure integration. This shows how a single platform can support diverse business functions. PaaS is designed to support the complete web application lifecycle, building, testing, deploying, managing, and updating within a single integrated environment. It often includes capabilities for continuous integration and continuous delivery, CI/CD, allowing you to automate your release pipelines. Furthermore, PaaS supports multiple platforms, enabling you to build and deploy applications that work seamlessly across web, mobile, and desktop devices without managing different infrastructures for each. This state diagram represents the application lifecycle supported by PaaS. It starts with build, moves to test, then deploy. Once live, the state transitions to manage, and finally update. The arrow returning to build illustrates the continuous nature of modern development cycles supported by PaaS environments. To summarize, PaaS sits comfortably between IaaS and SaaS. While IaaS provides maximum control over the stack, PaaS provides a mix of control and ease of management. It offers more flexibility than SaaS, where you simply use the software, but significantly less maintenance overhead than IaaS. Prominent examples of PaaS include Azure App Service, Azure SQL Database, and Azure Functions, all of which abstract the underlying servers so you can focus on innovation. This chart places PaaS in the cloud landscape. The x-axis represents management overhead, and the y-axis represents control. SaaS is in the bottom left, low control, low management. IaaS is in the top right, high control, high management. PaaS sits perfectly in the center, offering a balanced approach that optimizes for both developer productivity and configuration control.